Hello engineers. Today I will be discussing about a important topic, that is, when a three-phase fault occurs at any one of the buses, what will happen? Let us see that. First of all, here you can see that it is a P delta curve. Here P is for active power and delta is for load angle. Now the P delta curves look like this way. Okay. Now here you can see that a parallel line. This is the stable point. That means at this point of the curve, the mechanical input power equals to electrical input power. Electrical output power. Here I am denoting the mechanical input power as the PM. Hence the electrical output power will be PE. So at this point they are equal. Now suppose a fault occurs. When a fault occurs, this point will come down to that point B. If we consider that it is a point, then it will be B. Now, what is happened at this condition? Actually, in this situation, as a fault occurs, that means electrical power becomes 0. But here, the prime mover, you know that the prime mover is already there, and so mechanical input is constant. As mechanical input is constant and electrical output becomes 0, so you can say that the generator, that is the alternator, will accelerate. As it accelerates, the load angle will increase because the mechanical power is greater than the electrical power at this point. Electrical power becomes 0, but mechanical power is constant, so it will increase like that. Now at point C, let us consider the fault is cleared. So this is called the fault clearing angle del 1. Now when the fault is cleared, if it was operating point initially, now it is the operating point. Now if the fault is cleared, so operating point will shift to its original position where it should be. At this position D, the electrical output power will be greater than the mechanical input power because the load has come again. Now, since during this acceleration, the energy will be stored. Due to this energy, it will not deaccelerate initially, rather it will accelerate up to point C. When the up to point C, now at that point the acceleration energy will be exhausted. Now it will start to deaccelerate like that, and it will come to point A, and at point A it will oscillate for a while. It will be like here, 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 then it will again come back to its normal operating point. It is a stable point where PM equals to PE. Here you can see that this is the area marked, Now we can say that from equal area criterion, for the system to be stable, this area and this area must be equal. Another point is that here you can say that this point, that is the E, now corresponding delta value del 2, you can see that now this delta value can be increased up to maximum value that point. It is the F point because it is the stable operating point line. Now after this, if the operating point goes, then the system will be unstable. It cannot be come back to its stable operating point again if it becomes lower than the point F. So delta 2 max is called the maximum. So delta 2 max is the maximum value of delta. That means we can say that if for which value of delta 1, this point will come to that point, that is the delta max. This is called the critical fault clearing angle. Okay, so what I have told that for which value of del 1 del is equals to del max, this is called the critical fault clearance angle. So I think you have understood this process when a three-phase fault occurs at any one of the buses. So thank you. If you like my video, please if you like my videos, please like, share and subscribe my channel, and click the bell icon to get notified when I will post another new video related to electrical engineering. Thank you.